Hello, my name is Afshin Odabai. I'd like to show you the concept of digital power system management and how you can benefit from its features to take control of your system's power consumption and management. Managing power and implementing flexibility in a high rail count circuit board can be very difficult and requires engineering hands-on probing with the DVMs, oscilloscopes, and often requires reworking of PCB components. To simplify these tasks of managing power, there's a growing trend to configure and monitor power over a digital communication bus. In other words, implement telemetry capability to set, monitor, change, and log power parameters. This technique is frequently referred to as digital power or digital power system management, or PSM. It allows systems designers to simplify and accelerate system characterization and optimization during prototyping, deployment, and field operation. At Linear Technology, we use the word digital, referring to the ability to communicate information via a digital bus with the task of converting and regulating power using the analog methodology and architecture. The block diagram shows a typical way to control 8 point-of-load regulators with PSM. It includes several point-of-load regulators, a PSM block, digital bus, and a host to collect and transfer data. Digital power system management products are configured and monitored via a two-wire PM bus interface and open I2C-based digital interface protocol. This enables seamless integration with existing embedded systems and architectures, board mount controllers, BMCs, and intelligent platform management interface, IPMI functions. For simplicity and ease of use, especially at the earliest stages of hardware development and testing, a graphical user interface, a GUI, running on a PC is used to communicate with the PSM device through a USB to PM bus adapter board. Linear Technology's LT Power Play is a simple GUI capable of programming multiple PSM devices on the same screen in one session. The next 3 slides demonstrate the benefits of digital PSM for your design and, more importantly, your customers' systems. A key challenge is to reduce power consumption by understanding its precise usage from a broad range to detailed board level. For example, from large-scale server farms down to small-scale board mount power in each rack mount system. PSM products can provide the user with critical power-related data. One can access load current, input current, output voltages, compute power consumption, efficiency, and other power management parameters via a digital bus. This provides the ability to develop predictive analytics, minimize operating costs, and increase reliability for smart energy management. With Linear Technology's PSM products, you can take control of your system's power. The first benefit is voltage optimization. Output voltage accuracy of a regulator is critical in powering ASICs and FPGAs. The traditional power supply's output voltage drifts with time due to temperature variations and manufacturing tolerances. These voltage drifts may violate design margins. A digitally managed supply is constantly measuring the power supply output voltage with a very accurate and stable analog to digital converter. A time servo loop automatically adjusts the value of a trim DAC, canceling the power supply output voltage drift and greatly improving precision. The second benefit is the ability to dynamically control the output voltage. The traditional supply voltage is fixed and can't be easily changed on the fly. A digitally managed supply is adjustable via an industry standard two-wire digital interface with better than 1 millivolt of resolution. With Linear Technology's PSM products, you can fine-tune system performance and minimize wasted power, enabling techniques such as dynamic voltage and frequency scaling, reducing overall system energy consumption. The third benefit is system monitoring. In traditional power supply, system monitoring functions are usually separate from the DC-DC regulator. Overvoltage, undervoltage, and overcurrent faults can be detected, but not are all reported to a host controller. In the digitally managed power supply, power monitoring functions are built in and are programmable. Fault conditions for one POL can be easily combined with other POLs to create a customized response to a variety of fault conditions. With a digitally managed supply, detected faults are correlated with high accuracy measurements of voltage, current, and temperature. Internal non-volatile memory can store the information useful for debugging and root cause analysis. The exact sequencing arrangement of a system's voltage rails is often unknown until after board fabrication, and then supply ramp rates may need to be adjusted. Sequencing and ramping in a traditional power supply can be done, but the values will be static, adjusted with a board level change. With digitally managed regulators, power parameters are software configurable. Board level or component level changes are not required. Power parameter corrections can be done in the chamber, eliminating another requalification and delay in product launch. One obvious advantage is faster and simpler debugging and troubleshooting. With a traditional power supply, design is done with external meters and probes, which introduce measurement difficulties. The last example is margin testing. Margin testing is the practice of exceeding the limits of the power supply to simulate the worst-case performance. Margin testing is the only acceptable alternative to worst-case analysis, as worst-case analyses are very costly and time-consuming. Building margin testing into traditional POL increases complexity and is inaccurate due to manufacturing tolerances. In a digitally managed power supply, margin testing is built in and is very accurate. Because each POL can have its own margin levels, both high and low, complex patterns of power supply levels can be programmed over the digital interface. This provides a fast and easy way to achieve worst-case analysis of system-level performance. For more information on digital power management system, please visit linear.com. Thank you.